This is 8.3 Pythagorean Theorem, and this is an exciting section because a lot of you already know the Pythagorean Theorem, and for some reason you want to apply it to everything, and so we finally get to use the Pythagorean Theorem. So let's go right into the theorem. It is a theorem, right, as stated in the name, the Pythagorean Theorem. In a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. Okay, so let's break that down. So we're dealing with a right triangle. Okay, in a right triangle, and it's a sketch, so it's not perfect, but in a right triangle, the sum, so we're adding something, of the squares of the lengths of the legs. Okay, so let's call this leg A and we'll call this leg B. So we're taking the sum of the squares of the legs. So we're going to square one leg and add it to the square of the other leg is equal to the square of the length of the hypotenuse. We'll call the hypotenuse C is equal to the square of the hypotenuse. And that's where we get a squared plus b squared equals c squared. If you don't already have that memorized, you need to commit that to memory because you will use it so much, not just in geometry, but in higher math as well. So that is the Pythagorean theorem. A squared plus b squared equals c squared. Now, note, this is only applicable to right triangles. Right? It only applies to right triangles, but it will be valuable for so many other things because you can break up other polygons into right triangles, and so this is going to be used for other shapes as well. So let's look at how we can visualize this. So we have a right triangle here, and then we have the squares drawn in. And so this shows us that if side A, right, and this is our right angle right here, okay? If side A is 3 units long, 1, 2, 3, right, and we make that a square, we square that, then we get 9 units here. If side B is 4 units, 1, 2, 3, 4, and then we square that, make a square out of it, 4 by 4. This one is 16 units. Okay, and then that should equal, if we add those together, 9 plus 16 is equal to 25. That should equal the square of the hypotenuse. 1, 2, 3, 4, 5. 5 squared is 25, and that is correct. And so this is one way to visualize how that works. A squared plus b squared is equal to c squared, and I think that might be written out here. Yep, 3 squared plus 4 squared is equal to 5 squared, and that's how we can visualize the Pythagorean theorem. The converse of the Pythagorean theorem is also true. Okay, so remember the converse is kind of like saying it backwards. And so what we can say is we can say if a squared plus b squared is equal to c squared for a triangle, then we have an if-then statement, then the triangle is a right triangle. Okay, so we can use the Pythagorean theorem applied to right triangles, but we can also use it to prove that something is a right triangle. If you're given the lengths of the legs or a leg and the hypotenuse, you can use the Pythagorean theorem to determine if it is a right triangle. So theorem 8.8 is related to, it's derived from the Pythagorean theorem. I'm not going to show you that derivation or the proof or make you prove it. So just know that it is derived from the Pythagorean theorem. So now we're dealing with an equilateral triangle. The area of an equilateral triangle is square root of 3 divided by 4 times the square of the length of one side. So let's see what this looks like in equation form. Okay, so the area of an equilateral triangle, remember an equilateral triangle has all sides are the same. So this side is the same as this side is the same as this side. We can also mark it like this, which also means that these angles are all congruent. Okay, an equilateral triangle has 3 congruent sides and 3 congruent angles. So the area is equal to the length of one side squared times square root of 3 divided by 4. So let's go ahead and do an exercise with this. Find the area of equilateral triangle LMN. So let's pull up our formula here. The area is equal to the length of the side squared times square root of 3 divided by 4. And we're given here that our side is 7 centimeters, and because we know it's an equilateral triangle, they're all the same. We know that this one is also 7 centimeters and this one is also 7 centimeters, so it doesn't matter which side we're given. So let's go ahead and plug that in. We get A is equal to 7 squared times square root of 3 divided by 4, and then we can simplify 7 squared into 49. 7 times 7 is 49. Square root of 3 divided by 4 square centimeters. Now, I want you to notice that the answer is left with a square root in it. Okay, leave it that way. This is an exact answer for the area of this triangle. Okay, it's an exact answer. Because 3 is not a perfect square, if we were to change it to decimal form, we would have to eventually round it. The square root of 3 is not a rational number. It goes on forever. And so to write it down, we would eventually have to round it, and then we would get an approximate answer. So if I plug this into my calculator, what I get is I get 21.21762239, but that's just where the display on my calculator stops. This will actually keep going on forever. And so no matter how many decimal points I write, it is an approximate answer. So in general, unless an exercise tells you to put it in decimal form and round it, then go ahead and leave it with the square root there. Now, one thing is if this and if the number outside the square root and the denominator have common factors, you would want to reduce that to get the simplest form of the fraction. You can find your assignment on Google Classroom. And then one thing that I want you to note is that sometimes in your assignment, it will ask you to apply the Pythagorean theorem to something we've already learned. So for example, they might give you a parallelogram and ask you to find the area of the parallelogram. And we know that the area of a parallelogram is the base times the height, but they might just give you the base, and they might give you the length of this side, and they might give you the side of this triangle here. Let's just call that x. Okay, and you would need to find the height. And so the way you would do this is you would use the Pythagorean theorem. Okay, if you're solving for the height, then you know that s squared plus x squared is equal to h squared, and you can find the height and then plug it into the area formula. So let's go ahead and do one together so that when you get there on your homework, you're not lost. Let me erase this. And then when you do get there on to this one specific one on your homework, you can just copy it. This is number 17 on your assignment, and number 17 gives you, sorry, this is a horrible sketch, but you get the idea. You can look in your book. This is 15 units long, this is 12 units long, this is 5, and this is a right angle. Okay, and so we are supposed to find the area. Okay, find the area. And so we know that the area of this shape is going to be the base times the height, and we are given the height of 15. Sorry, not the height, we're given the base. I am so sorry. The base is equal to 15. So we need to find this height. Remember, the height is found by a vertical angle that goes from one base to the other. a vertical line that goes from one to the other and meets the bases at a 90-degree angle. Okay, and so we're going to use the Pythagorean theorem to find this. So we know that this is the hypotenuse. So in the Pythagorean theorem, a squared plus b squared is equal to c squared. The hypotenuse is going to be our c. Okay, it's always our c is our hypotenuse. And then this would be one of the legs. It doesn't matter if we call this a or b. So I'm going to say a squared plus 5 squared is equal to 12 squared. Okay, so then I can move the 5 squared over. A squared is equal to 144. 12 times 12 is 144. And then I have to subtract 5 squared, which is 25. Okay, so then I'm going to do a squared is equal to 144 minus 25 is 119. Okay, and then I need to get just a by itself. So I need to take the square root of 119. So a is equal to square root of 119. Okay, and 119 is not a perfect square, so I'm just going to leave it like that. Remember, do not put it in decimal unless it is requested. Okay, so now I found my a. That is the height. A equals height, which equals square root of 119. Okay, so I found that, but now I need to find the area of this shape. And so I can plug in the base is 15, and the height is the square root of 119. And so that would be our answer for the area of this shape. Now, remember, we had to go through the Pythagorean theorem in order to get that height. So if you have any questions, please let me know so that I can direct you to more resources or help you out.